Today we're going to learn about exponential growth and decay. We have taken a look at exponential functions and their graphs, and we've noticed and found differences between an exponential growth graph and an exponential decay graph. Today we're going to solve problems involving exponential growth and decay using formulas. So our exponential growth formula is y equals a times 1 plus r all raised to the t power. So it's important to really know what these letters stand for. Y is the final amount of whatever you're working with, depends on the problem. A is the initial amount. R is the rate of change, or the percent, expressed as a decimal. So remember when we have a decimal, if we have something like 15%, we want to express it as a decimal. So we move the decimal place 2 times to the left, so our decimal would be 0.15. So we have to remember to do that whenever we're working with a percent. And t is the time, and the time could be in days, weeks, months, years. It really depends on the problem. So here we have our first example. It says the prize for a radio station contest begins with a $100 gift card. Once a day, a name is announced. The person has 15 minutes to call, or the prize increases by 2.5% for the next day. Write an equation to represent the amount the gift card in dollars after t days with no winners. So again, we take this standard form of the equation, y equals, now a is the initial amount. So the initial amount of the gift card is $100. So 100 times always 1 plus. Now r is our rate, and our rate is a percent, 2.5%. But remember, we have to move that decimal 2 places to the left. So it would be 0.025. So 0.025. All raised to the t power. So here we have our equation. After t days, what will the gift card be? So here it says, how much will the gift card be worth if no one wins after 10 days? So in this particular problem, t stands for time, and time is the amount of days that pass. So we would take our equation and we would write y equals 100 times 1 plus 0.025 raised to the 10th power. We would type this whole string, so remember, not the y equals, just this string right here, into the calculator, and we would get 128.008. But remember, we're dealing with dollars and cents, so we would round this to about $128 even. Okay? Now, the equation for exponential decay is almost exactly like the exponential growth formula. However, you'll notice that the plus sign in the exponential growth is replaced with a minus sign in the exponential decay. The letters in the equation all mean the same thing, where a is the initial amount, t is the time, r is the rate expressed as a decimal, and y is the final amount. Our example 2 says a fully inflated child's raft for a pool is losing 6.6% of its air every day. The raft originally contained 4,500 cubic inches of air. Write an equation to represent the loss of air. So we have y equals, a is our initial amount. So initial amount of air that was in the raft was 4,500. And then we multiply times 1 minus r, which was our percent, 6.6%, but I can't leave it like that, so I move the decimal twice to the left. And it becomes 0.066, all raised to the t power. Part B says estimate the amount of air in the raft after 7 days. So we would say y equals 4,500, because we're looking for y, which is that final amount, times 1 minus 0.066. Instead of t, we're going to put our 7 up there. And when you type in this entire string without the y equals into your calculator, you'll get y equals 2,790.23, which is about 2,790 inches cubed or cubic inches of air after 7 days. So let me just fix that for you. Okay, please make sure you fill out the Google form. Come prepared to discuss this and exponential functions tomorrow during class. Have a good night.